is this, had I done that in class before, last time? Factor theorem. And divide with synthetic notation. We'll go ahead and start right here, unless I've already done this. Okay. What is the remainder theorem? Who remembers the remainder theorem? If you get a remainder, then that's not a zero, or x plus 1 is not a factor of the equation. If you don't get a zero, if you do get a zero, then that is a solution, and also x plus 1 is a factor of the equation. Okay, now that's what the remainder theorem says. So let's do the synthetic division on this. We're going to divide by -1. That means the factor is x plus 1. We put in all this. We've got some missing degrees. That's why we got these zeros in here. So we bring down, we multiply, 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 we bring down. This is getting repetitive. We bring down, we multiply, and in this case, we do get a remainder. Now, that's a yes. Okay. Not a total loss. Even though that's not a point on the x-axis, -1, -1 is a point on the graph. So it still gives you a XY table point on the graph without having to calculate it. Okay. So I guess that's its only redeeming value. Okay, we're gonna go to this one. Use that to show that radical 5 is a zero of this. Now, if there's a radical 5, there better also be a negative radical 5. Just know that. If it is. If it's not, then it's not. So we're going to put radical 5 in the box, write down the coefficients, and do it. I probably ought to explain to you about this stuff. Obviously, I just wrote down the first term. I multiply this times that, and I get radical 5. These are unlike terms, so all I can do is write them down next to each other. Now, I have to take this radical 5 times that by distribution. So I take the radical 5 times the -4, and I get this term. I take the radical 5 times the radical 5, which is radical 5 squared. So I just get 5. Okay. Now I add these two conveniently canceled, leaving me this. Now I have to take the radical 5 times this again. Well, radical 5 times radical 5 is 5 times -4 is -20. Okay. And we add down, we do get a zero remainder. Okay. So that tells us that in this case, x minus radical 5 is a factor. Now, watch this. This isn't part of my slide right now. Okay, this isn't part of my slide. Let me get rid of that. Well, actually, I could leave that there. What if I do this with the negative radical 5 this time? What if I did that? Yes,
I have a question. So what would the total answer of that be?
started out cubed. So this would be 1x squared, or x squared, 1 degree less, minus negative or plus -4 plus radical 5 x, 1 less here, minus 4 radical 5. And that's kind of an ugly thing, but that's what it would actually give you. Okay, did I answer your question okay? Well, this thing would even be difficult to do in the quadratic formula, although it could be done. It'd be a nightmare. But let's watch what happens here. Since I know that conjugates have to be on the radicals, then I can do this. Bring down this 1. This times that is negative radical 5, right? These two combined gives me -4. This times that gives me positive 4 radical 5. Bring them down, and I get a 0 remainder this time. Okay, here was my remainder line the first time, there's my remainder line the second time. Now, what does that mean? Well, since it's a 0 remainder, that means I've got this. Well, if this was the x squared term, then this is just simply the x term. So I've got the factor x minus 4. Factors in this problem are x plus, in other words, minus a negative radical 5, and x minus radical 5. Those are the 3 factors of that. And likewise, minus radical 5 and positive 4 are the x values. Okay, earlier on, I told you that this synthetic division and long division were nothing more than an alternative method of factoring. So what we have done is we've factored this unfactorable equation. Okay. And by successive ones. Now, if we hadn't have known the fact that those come in, we couldn't have done this. We would have just been kind of hanging after our first one. Okay. But what I just showed you is kind of the big picture of the whole thing, even though it really wasn't supposed to be in this problem yet. That's as far as we were supposed to go in this problem, the way it's written. Okay. Now, difference here, we're throwing in imaginaries. Yuck. If we've got a positive imaginary, then we got a negative imaginary, just like if we had a positive radical, we got a negative radical. Because those always come in conjugate pairs. Okay? Now, so we're going to divide by 8i. What that means is really we are testing x minus 8i as a factor. So, do we have any missing powers? No. So there's our numbers. Let's look at this, what we did here. We brought down the 2. 8i times 2 is 16i. We can't combine these unlike terms. And I really would put those parentheses around these. Okay, so I've got that. Now I need to take this times this by distribution. 8i times 1 is 8i. 8i times 16i is 128. Okay, let me show you what they did here. 8i times 16i is 128i squared. Okay, which we replace the I squared with -1. So that's how they got this minus 128. Okay? Anyone not understand what I'm saying on this? I need to explain it more. Okay. So anyway, these two cancel each other out, just leaving this 8i. 8i times 8i, kind of like over here. What they did was 8 times 8 is 64. I times I is I squared, which is 64 times -1. So that's how they got that. Whereas this was a plus right there before. And we got a 0 remainder. Now, in this case, we knew that we better because it says it is. Do you want to finish this one to full factoring, or do you want to go on? We can do it either way. You'd like to know how to finish this. Okay, we got this. Now, this is 1 degree reduced. This would be, now I'm going to erase this in a moment, but this would be 2x squared, and this would be x here plus that. And of course, this is the remainder. Okay. So we now have this factor times that factor, which is pretty ugly. This time, here's going to be my remainder line. I bring down the first term, 2x, or just 2, the number. I'm not going to use these. Fact is, I'm going to erase them now, so they won't get in the way. Okay. So I bring down the 2, I multiply, and I get 16i, just like I did last time. These two, and this is a positive 16i, right? So that means I've got, when I add these down, I get 1 plus 32i. Now I take this times that. I get 8i. Okay. Oh, wait a minute. Duh.
It's supposed to be a negative.
This should be a negative 8i this time. So my signs are all screwed up. This should be a negative here. And I don't know what this should be. I got to start all over because I majorly messed up. If that we did 8i there, we got to do negative 8i here. Bring down the 2, multiply, we get negative 16i. Those two right there cancel, leaves me 1. Okay, this times that gives me negative 8i, which gives me a 0 remainder. So this represents 2x plus 1 as a factor. So if that whole equation were totally factored, then you would have x minus 8i times x plus 8i times 2x plus 1. And actually that could be rewritten as x minus, x minus 1/2. This and that mean the same thing. Okay. So anyway, there's your full factorization on this one. I don't think you're gonna like the next problem very much. Well, no, this is just a review. This is just a problem showing that if you had this original equation, if you did it by long division, and you did it by synthetic division, you'd end up with the same result. That's all that is. No point in writing that down unless you just like it. Okay, here's some more. We're gonna jump through those and go into this. Now, the factor theorem, these are reversal statements. Don't write this down. Don't write this down. If x minus 3 is a factor, then x equals positive 3 is a 0. If x minus 3 is a factor, then x equals 3. That's all that is. Just fancy language. So don't let that stuff intimidate you. Okay, now use this column. That means we're going to divide by that factor. Here we did long division, and you got that answer. Okay, that means you got this times that. That you either use the quadratic formula or factor itself to take it all the way down. Okay, when you get down to second degree equations, you can either use quadratic or normal factoring methods most of the time. Okay. Well, here's just more of the same on that. Let's go to this one. They're saying if this is a factor. If that's a factor, then this would be the solution, but we don't know if it is or isn't. You do it. You do it. I'll give you a hint. We're going to divide by -4. Okay, everybody get that far? They didn't ask you to take this one all the way down. Okay. Because we don't have any conjugate factors this time. We don't know any guaranteed ones to divide by yet, which is where we're headed just momentarily. Okay, everybody get this answer. If you didn't, fix it. Okay. We could put that in the quadratic formula to get our other two x values. Okay. And by the way, that is not right. That should be -40. That's bad enough. I better fix it now. I don't know why that's that way. Whoops. Where did I go? There we go. There, that's better. Okay. Here's one. This one, they're trying to determine whether x minus 6 is a factor. Okay, fifth degree equation. So if this works, then we've reduced it to a fourth degree, which means we still got a whole bunch more work to go ultimately. Well, there's the 0. So here's our long division, or our synthetic division rather. Pretty straightforward numbers. We put the variables back in, so we hit, since I had a 0 remainder, that means this becomes this factor times that. Well, guess what? 4, 2, twice as big. That means we can factor this normal methods. Okay. That means here's minus 6 carried over. If this were a square and that were just a 1, then these would be 1s right here, first powers. But I got these 3 factors. Now that one will break down more. That's a conjugate. Okay. So that will break down into these two. This one we still don't have broken down. Guess what? That one won't break down. It's imaginary, but we can get a solution from it. How do we get the solution from this? We use the 0, our property of square roots, to do it. So what we would do for this piece right here is we would say 4x squared plus 1 equals 0. 4x squared equals -1. Then we would take the square root of both sides, plus or minus. Okay, this is going to give us 2x here. And this will give us plus or minus I. Divide both sides by 2. And we get x equals plus or minus 1/2 I. So my 4 roots, because this is our 5 roots rather, I've got 2 right here. This one gives me a -1. This one gives me a +1. And this one gives me a +6. 1, 2, 3, 4, 5 roots. Okay. So sometimes, even though we don't know, we get ourselves in a position where we get lucky. But you got to be alert to that sort of a thing. Okay, now we're gonna go backwards direction. We've been starting with zeros and going to the equation. Now we're gonna start with the, I said that backwards. We've been taking the equation, a known equation, and dividing stuff out of it. This time we're taking the zeros and multiplying them to get the equation. So that now I said it correctly. But what does it say about this? This is a third degree equation. And it's got zeros of 2 with multiplicity 2. What does that mean? That means we've got x minus 2 times x minus 2. Okay, or x minus 2 squared. And then we've got minus 5, which would be x plus 5, or down here, x plus 5. So here would be the factors of this thing. Based on this, we could certainly graph this problem right now. Okay, but we don't know the y-intercept yet, although we could figure it out. Now, let me erase this stuff, but I wanted to show you that first because I wanted to explain the language they are using, because you will see it again. All right, here we go. That's what I just said. Now, take this one, multiply it out, you get that. Bring that one down. Now we're going to distribute. Here are the x distributions, and here are the 5 distributions. Okay. And we're going to combine like terms. And there's our full polynomial of degree 3. Didn't it? You just take the zeros, convert them to factors, and then multiply out the factors. So it's kind of simple in concept. It's just a pain in doing. Anyone not ready for me to go on?
So instead of doing -5, you do the opposite of sign?
Yeah, when we go to factors, it's always the opposite.
Okay.
Because if x equals 5 or equals -5, take this over to this side, plus 5 plus 5, we would get x plus 5 equals 0.
Okay.
Okay. What do we got on that? We got 1/3, and we got these two. So what would that give us? X minus 1/3 is the same thing as equals 0. Okay. Excuse me. If x equals 1/3, then I can multiply both sides by 3, and then equals 1, and then take this over -1 minus 1. 3x minus 1 equals 0 is the same thing as x minus 1/3. Those two are the same factor. Okay? And it depends on whether you like dealing with fractions or whether you like dealing with whole numbers. Personally, I'd rather deal with whole numbers. Okay? So what we're going to do is we're going to take this thing, this 3x minus 1 times x minus radical 3 and x plus radical 3. So here are my factors. 3x minus 1 times x minus radical 3 times x plus radical 3. Okay, that's what that tells you up there. Let's do these conjugates first. I'm just going to bring down the 3x minus 1. I'm going to have first term squared, x squared, last term squared, 3, with a minus between, using rule C off of my factor multiplication chart, page 10. Okay, so this piece was actually very easy. Now I need to distribute this. 3x times x squared gives me 3x squared, or x cubed rather. 3x times negative 3 gives me minus 9x. X times x squared is x cubed. Okay, and then here I had 3x times that is negative 9x. Now I'm going to do my 1. Negative 1 times this is x squared, negative x squared rather. And negative 1 times this is positive 3. So I combine like terms, which I have none, but put them in order. And there is my polynomial, third degree. Okay. Okay, we look at this and you think, oh, scary again. But remember, this is just, here's 4 and here's x cubed. Here's negative 13 and here's the x squared. Here's the negative 32 and here's the 1 more degree less x to the first and so on. Okay. And what this is saying is let me back up. This whole thing, bad time to leave. Really bad time to leave, but go ahead if you must. What this is saying is this is the way to pick out possible roots of an equation, to take the guess out to some degree. Okay, now think to factoring. What was the first thing we found? The multiple pairs on the n numbers, didn't we? Mm-hmm. This is going to tell us in these two sentences right here, okay, that you're going to use those first numbers and those last numbers and their factors in the process of what are some of the possibilities. Okay, you got the possibility of any of them that are factors of 15. 1, 3, 5, 15. You also have the possibility of the factors of 1 and 4, but what this is saying is for the 1 and the 4, or 1, 2, and 4, excuse me, is it's going to be in the denominator, whereas the factors of the 15 are going to be in the numerator. Okay, so now we're going to do some examples showing how this thing works. Well, this is just more the constant term on the end, the leading coefficient. That's what I just talked to you about. So we got this problem. That's just in term, first term. Okay, those are the ones we care about. Now, it says list all possible rational zeros. Word rational because they might be a fraction. Let's look at 15 first. We got plus or minus 1 could be a possibility. We've got plus or minus 3 could be a possibility. We've got plus or minus 5 could be a possibility. And we got plus or minus 15 could be a possibility. This is no more than when I had my pairs of 15 and 1, 3 and 5 before. Okay? Now, so all of those are possible numbers to divide by with synthetic notation. Possible, not guaranteed, possible. Anything that's not those, not possible, except what I'm about to show you. Now let's deal with the leading term. Factors it of 1, 2, and 4, right? Numbers that'll divide into 4. Well, 1 is a non-player. It ain't going to change anything. 2 could make a difference. In addition to this list, we now have plus or minus 1/2. We now have plus or minus 3/2. We now have plus or minus 5/2. And we now have plus or minus 15/2 as possibilities. Okay. Now let's do the 4. Well, we could have plus or minus 1/4. We could have plus or minus 3/4, plus or minus 5/4, and plus or minus 15. That means there are 12 different possible numbers that we could choose to pick from to divide into. Now, let's work smarter, not harder for Carter. Which one's the obvious ones to try first? Okay? Those are just the obvious ones to try. Okay? And then you might try these. I would try that one probably as a later resort, and I would try any of these as an absolute last resort. Okay, because I don't want to divide by those. Now, that's what this rule says. This rule says that if you take this thing, you take all the factors of this, possible factors, and you take all the factors of this and divide it into those, that's every possible real rational number that exists that you could come out with a zero remainder when you do synthetic division. Okay. Now, does that guarantee the problem will be? No, you could have an imaginary. But this just says the rational zeros, which is the real ones. Okay. So that's what this rule is about and how it works. And by the way, you're going to have a test question 90% likely the final, just like what I did. Now, notice how I laid that out. I wish I hadn't erased it already. I started from low to high with this one. Then I just brought them down 2 columns for each one of these. If there had been another one of these, then I would have had another row down there. Okay. But that way you've got it organized so you don't skip something. Okay. All right. Now we can go on. Well, they're just going to show you what I just showed you. I think mine is more organized than theirs. First place, they did the pairs and here as well. And then these seem to almost kind of become random almost, it seems like. That's why I like to do them 1, 3, 5, 15, and then the divisions directly underneath it, so I don't lose track of anything. Okay, not to mention it makes it easier to grade if you do it that way. Okay, what about this one? Go ahead if you need to. Okay, you get the notes from somebody. All right, here we go. I got a 3 on the end, I got a 2 on the front end. That one's easy. It's 1 and 3 plus or minus, right? Factors of 2 are 1 and 2. The 1 isn't going to make any difference. So basically, we're going to have the 1, the 3, the 1/2, and the 3/2. And that's all this question is asking us to do, is just find them. What are the possible rational zeros? Anyone have a question on this one before I go on? You look a little uncertain about something.
Plus minus 2 would be in that.
Say again?
Plus minus 2 would also. be
No,
in
no,
that
these
list.
only go in, the leading term only goes in denominators. Okay? The ending term is more important. That's why it gets its own full set. Okay? Right, that's kind of a silly way of saying it, but I guess it works. Okay. Well, now what are we going to do here? We're going to take this equation and we're going to try one of those. Well, which ones did I tell you are the obvious first tries? Plus or minus 1. So what they're doing is they're trying plus 1. And we got a 0 remainder. That means it works. Okay. So we now have this factor out here of x minus 1 is one of our factors from that original equation. You know what? I probably ought to write the original problem up here somewhere. What was the power on this one before? Do you remember? Fourth. So I had 2x to the 4th
Minus x cubed,
plus
plus x cubed.
plus x cubed minus 5
X
squared
minus
minus x
plus 3.
plus 3. Okay, so that's gonna be one of the factors. Now, you know what? With this many to start with, I could try positive 1 again, or I could try negative 1, would be my next two easiest choices. Okay. Well, they tried positive 1 a second time. Got a 0 remainder again. Because remember, here was your remainder this time, here's your remainder this time. Okay. So what this means then, I've got another x minus 1 here, or x minus 1 squared. Multiplicity 2. That means it's a touch and go point. Okay. To go back to what we talked before. I've got this now. I've got this thing now from a 4th degree equation to a 2nd degree equation. This I could factor normally. I could throw it into the quadratic formula if I wanted to do it that way. Now, if I wanted to gamble, I need to try some variation of a 2 or 3. Now, I'm going to tell you something else. See these two negatives up here? Probably there's somewhere in this thing a negative 1. Probably. Or a negative something. Okay? If this thing was all positives, then you would never try anything but positives. But if it's got some negatives in it, somewhere you got a negative x value. Well, let's go on and see what they do. Okay, that generates x minus 1 again. What have I got left? Well, I've got this 2x squared plus 5x plus 3 so far. And now, like I said, I can either try to factor that or use the quadratic formula if I want, or I can try either some variation of 2 or 3, or 1/2 or 3. Well, here's what it turns out to be. This one is actually the same thing as x minus 3/2. This and that are the same. Okay. So that's what your roots are on this thing. Okay. And that, whoops, went too fast. And that would give you a 0 of 1, multiplicity 2, of -3/2, and also -1. I better clarify that. There we go. So now we could graph this thing, and by the way, there's the y-intercept. So you got 1, 2, 3, 4, 5 points we can graph and get a pretty good quality graph out of it. A different problem this time. Got a minus there. That means I'm going to have a minus in this thing for sure somewhere. Okay. Well, here are all possible factors. Because that's the 1, the only possibles that we can divide out are 1 and 5s. Okay. I could try that. And I did, and I got a 0 remainder. Okay. Now, I have reduced this thing to that. And you know what? That won't factor. That won't factor. There in any way with a 1 here and a 1 there, you can get a 3 there. Okay. So that we can't factor that. We could put it in the quadratic formula, and we'll either get a radical or we'll get an irrational. I mean, either a radical or we'll get a imaginary for our answer. Okay. You need to take those looks at that kind of stuff. See what you got. Well, 5 is a 0. You got that. And again, it won't factor. So they chose to do the quadratic formula on it, which I told you was one of your 2 choices. Okay. And when they go through the steps, they get this. Okay. Now, in radical form, that would be good enough. But in this class where you got a calculator, it's not good enough. Let me illustrate what you would do with this so you can find your x values. Okay. Let's put this in here. Let's do the plus side first. So I'm going to first put in a fraction. Then I'm going to put -3. And then I'm going to use the plus side. Square root of 5. Use this arrow to get down to the basement. Put in the 2. And hit the equal sign. Now, technically, I should get out of it completely, but it still would have worked if I'd left the cursor at behind the 2. And it said, well, what the heck is that? Well, scientific to decimal key. And there it is. Negative 3.381. Okay, approximately. Because that is a rounded off value. Okay, so that means in this particular problem, so far, we have factors of x minus 5, root of x equals 5. We've got x equals negative 381, decimal point there. And now we need to find the minus side of this quadratic. Rather than starting all over from scratch, I'm just going to back up until I'm before that plus sign right there. I'm going to delete the plus and put in a minus. And then hit the standard. Well, got to get out of there. Okay, now I can do it. Equals and standard decimal. And this time I get approximately negative 2.618. All right. Now, graph wise, if I want to graph this thing, graph paper. Okay. The 5 is easy. Okay, right here. Negative 3.81. Well, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3.81 in reality is approximately negative 0.4 or negative 2/5. Approximately. Very rough rounding. So that means this one's going to be 2/5 of the way, or a little bit less than half. A little bit less than half. Okay, let's look at this one. Okay. This means it's going to be a negative 2.6 approximately, or a little bit more than half. Okay. So here's 1, 2, and a little bit more than halfway. Now, what do we know about this equation ending values? What direction is it going to go? It's cubic, so it's going to go down to up because that's a positive cubic. So that means this endpoint has to go down that way, and this endpoint has to go up that way. Okay. What else do we know on this graph? Well, we know that negative 5 right here is the y-intercept. Okay. So that means this thing's got to go up some, like this, up pretty high probably, and come down at a real steep angle like this to some point about halfway between those, and then turn and come this way. So that means that's what this graph is going to look like. Now, do we know what these 2 points are? No. Do I really care? Not unless I say it has to be precise. How would you do it if you cared? Well, I'd try about halfway between 0 and 5 with an XY table, and halfway between almost 3.5, or in other words, between 1 and 2, somewhere around here. I'd try to get it if I wanted to, if I cared. If it was necessary, that sounds better. Okay. But that's how all of this stuff fits together. That's the big picture in one problem right there.
So we have to graph that? Because that-
No, this one didn't tell you to. I just wanted to show you how the thing would play out to its full completion. Okay, if you had to. But no, in this one, you didn't have to. Okay, oh, I know why this isn't working. It's because I don't have it in that mode. And I've just got to run down through their work real quick on this one. And this one we're skipping, and that one we're skipping. Don't you like my warning sign? Okay, what, and this one, look at the wording there, look at this, and the rest of it we don't necessarily need to worry about for right now. Just look how they set it up, okay? This one, you're starting here, you're finding the ending equation, multiplying the factors together. Okay, this one, yucko. You got your pair, even though they tell you only one, and by the way, they're probably going to do that on the final. They're probably only going to tell you one imaginary, and you got to know the other one's there. Okay, same way with a radical, it could be. Some semesters they do it with radical, some semesters they do it with an imaginary. You got to know that this one is a multiplicity too. So you got a pair of them. That pair multiplies out to this. Those two are conjugates, so they're easy. How did they get +9? Because you got an I squared that you got to convert. Okay, these two distributed here, the x squared and the a, you get, or the 9 rather, you get that string. And we don't know a term in or not on this one. Okay. We assume it's a 1 unless it gives us a hint that it's not. So let me get through all of that stuff. Let's go to this one. Uh-oh, this is something new. I've got a handout on how to multiply those things. I don't remember the page number. It's a handwritten handout. Okay. It's a handwritten page on how to deal with these complex imaginaries. Okay. Now, what this is saying, if that's the factor, if that's the 0, if x equals 1 minus 5i, then x minus quantity 1 minus 5i if x equals 1 plus 5i, then x minus 1 plus 5i is the factor. Okay. If the problem in this case were to multiply out the factors to get the equation, that's not what this problem is asking. But I want to say this right now because I'm starting to run short on time. Notice that both of these are minuses out here. Your conjugate part is inside the parentheses. Now, eventually, these two will simplify. This one will simplify to x minus 1 plus 5i. And this one will simplify to x minus 1 minus 5i. And these are what you would actually multiply together. Okay, a 3-on-3 distribution. Okay, multiply everything by this one, multiply everything by that, multiply everything by that, and you're going to have some I squares to deal with. Okay, now in this particular problem, I just want to show you the I want to show you the synthetic division on this. Because now we got this in front. So it makes it just a little more complicated, okay? Or a lot more complicated. I've got to put some parentheses in. I need to put a parentheses in there and here. I want to put a parentheses in here and here. Okay? That way we don't lose track of something. Now, given that, bring down the first term, okay, from that equation. Now, and this tells us that this is a factor, so I better get a 0. Now, 1 times this is itself. That's pretty simple. I can only combine this 3 and this 1 and bring the 5i down with it. So -3 and 1 is -2. Now I've got to take this. To do this, I've got to go off on the side. And do this. -2. -5i. Negative or positive 10i. And positive 25i squared. Now that doesn't look like what they've got. So let's see what happens here. This is a -1. Okay, so that makes this -25 plus 10i. Okay, if I did that correctly, and apparently I didn't. What did I don't do correctly?
You have the -2 minus 5i.
I did what?
You did -25? Why'd you do -25? Because I squared is -1 and that.
Okay.
25 is negative.
I can't leave it like this. Let's do this again. Oh, I know what I did there. Okay, I'm first multiplying by this 1. And I get -2, and I get -5i. Okay, now I'm multiplying by this. I've got -5 times 2 is positive 10i. I take this times that, and I get positive 25i squared. Okay. Replace the -1 and this becomes -25. -25 and -2 make -27. And these two make +5i. That's where that came from. And you got to be careful, obvious. Okay, well, the 27 and the 28 will subtract, leaving a +1. The 5i just comes down. Now we got to do this same business again. That times that. Okay, those two are conjugates, so that one's actually easy. Okay, we're going to get first term squared minus last term squared, which is 1 minus, in this case, 25i squared, which is 1 minus or plus 25 like that, or 26 is how that came about. Subtract these, 0 remainder. Okay, so I had to go through and show you how to do this stuff, so you'll be on track with Alex. Okay, and I think that's where I want to stop. Let me look at one. Okay, This business over here is just multiplying this out like I did over there. Is all that is. Now, here are the zeros associated with this thing. They went on, let me erase this so I can show you this. We did this work with 1 minus 5i. If this one's here, that one's got to be here also. So they did it again. Like so. Okay. And they got this. Well, this translates into x minus 1. So look what we had then for our zeros. We had this, and positive 1 would be our 3 zeros for a third degree equation. Okay. So this one does work on our system just like the others, and there's the factors and the solutions. You could be asked to express the answer either way. So this might be something worth either writing down or photoing. Okay, because you might have to put the answer this way, or you might have to put the answer one of these 2 ways. By the way, if you multiply this times this, you will get that original equation. And with that, yes, question.
Actually,
You sure?
Yeah.
Bye. Your rest. Page 13 shows you that complex multiplication. Page 13.
Excuse me, I have one question about one of the slides.
Sure, let me.